In the first equation, I can see that 27 can actually is a power of 3. It's 3 to the third. So we'd go 27 equals 3 to the third. So I'm going to create a new equation. So we're going 3 to the 2x equals 3 to the third. So if the bases are the same and equal to each other on one side and the other on the equation, that means that the exponents are equivalent, are equal to each other as well, because this whole thing is equal to this whole thing. So we can actually rewrite this as, we can get rid of the bases and just write the equation 2x equals 3. And then simply dividing both sides of the equation by 2, we have x equals 1.5, 1.5. Our second equation, I'm looking at the two bases, 7 and 21, and I'm saying to myself, well, I can't rewrite I can't rewrite 21 as a power of anything that would equal 7, nor can I do that with 7 to 21. So when that's the case, that's when you take the log of both sides of the equation. And the reason I'm taking the log of both sides of the equation is because I see that the variable is in the exponent position. And using my power rule, I can take this negative x now, and I'm going to put it out in front of this log. And now I'm going to use my algebra tricks. How do I isolate this variable? Well, it's being multiplied by log 7, so I'm going to divide both sides of the equation above by log 7. Please do not go 21 divided by 7 and go 3. Don't do that. You go like this, you cancel those logs, so you have negative x equals log 21 divided by log 7. And now we find log 21 divided by log 7. Log 21 divided by log 7. I get 1.565 if I round to the nearest hundredth. 1.565. So negative x is equal to 1.565. And then how do I get this x isolated? Well, I can either divide or multiply by negative 1. I'm going to multiply by negative 1. What I do to one side of the equation, I have to do to the other. So I get x is equal to negative 1.565. And that's an approximation. And I'm going to do the same thing in 1c as well. So I notice that 2 and 15, there's nothing there. There's no way that I can rewrite either of these numbers as a base so that they have matching bases. So I take the log of both sides. And again, realize that that variable is in the exponent position. That's why I want to do that. So from here I'm going to go log 2 to the 3x is equal to log 15. Now I'm going to take this exponent right here and I'm going to bring it out in front as a multiplier. So now this becomes 3x times log 2 equals log 15. And then I'm going to divide both sides of the equation by log 2. So now I'm left with 3x equals log 15 divided by log 2. And then I'm going to divide both sides of the equation. Now I'm trying to find x, so I'm going to divide both sides of the equation by 3. So I'm dividing this whole thing by 3. So let's do that. So we're going to go over here, and we're going to go log 15. So clear that out. I'm going to go log 15 divided by log 2. And I get an answer, and I'm going to divide that by 3. Approximately 1.30. X is approximately 1.30. Done.